Assalamu alaikum my dear students, how are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of Shahjadi English Medium School, BSS. Today I am going to take a physics class for class 9 students. My dear students, our today's topic is Chapter 5, Discussion Part 2. Our today's lecture number 12 and SW number 9. So my dear students, let's start our class. This is Chapter 5. Okay, at first today we will discuss this lesson, uses of density in our daily life. Density plays a vital role in our daily life. Sometimes we do not notice it separately. For example, when we take water in a pot and heat it, after a while the water starts to boil. It happens because when the water in the lower portion of the pot becomes heated and expands, then its density increases. As the density becomes less, the water goes up and cold water in the neighborhood comes down. After some time, this water also becomes heated and goes up, and so within a short period of time the water starts to boil. My dear students, the process of heating gas or liquid in this way is called convection. If density of water was not reduced after heating, then it would not go up and we could only heat the water in the lower part of the pot by fire of the stove, and it would not be possible to heat the whole water of the pot. In intense sunshine in summer, those who have jumped into a pond have surely noticed that though the surface water is hot, but the bottom water is cool. Here the heat comes from above, and after heating the top water density decreases and remains above. The whole water of the pond cannot be heated uniformly. Now another uses of density in our daily life, we have seen the balloons flying at the inauguration of various events. In order to make balloons fly, we need to insert gases lighter than air. Considering safety, they should be filled with inert helium gas, but helium gas is comparatively expensive. So frequently it is done with hydrogen gas, which is very dangerous. Not only that, as methane gas is lighter than air, which is used as a fuel, sometimes used also fill the balloons, and which is also similarly dangerous. We have often seen air balloons. Fires are lit under the balloons, which heat the air inside and make it lighter then this help lift the balloon up. We can determine whether the eggs are good or rotten by submerging them in water. If the eggs have gone bad, their density becomes lower and then that of water, and they start to float. Okay, my dear students, from this above discussion we have learned that when density decreases, then the object or substances start to float. Okay, then now come to this lesson, pressure in liquids. Those who have jumped in water, they all know that after going into deep water, pressure is felt. Okay, though atmosphere applies as a pressure on us, but we don't feel it because our body also applies the same pressure. So exactly what amount of pressure will be felt after going to deep water or any other fluid is already been mentioned. The pressure on you will have to be calculated from the weight of the column of liquid on you. Let us suppose that you want to determine the pressure of liquid at depth H. See this figure, my dear students. See this figure, here is given a figure. This is H. This is depth H. Let us suppose that we want to determine the pressure of the liquid at depth H. Imagine an area A there, and the weight of the column of liquid above this area will exert on force on A. Now volume of the liquid over a surface area A is AH, here given. My dear students, here area, if area is A and depth is h. So volume will be area into depth, that means A. Okay, this is the volume. Okay, if the density of the liquid is rho, then the weight of this liquid or force is H equals to mg. Okay, and we know that M equals to AH rho into G. From we know density rho equals to M divided by G. That means M equals to rho into G. So M equals to rho into G. That's why this is rho into G. G means AH. G equals to, we know volume, G equals to AH. So AH into rho into G. So this is the force equals to AH rho G. Okay, this is the formula. My dear students, memorize this one. Okay, and therefore pressure P equals to, now we can find out the pressure P equals to F by A. This is the formula of pressure, and then put the values. F means AH rho G divided by A. So H P equals to H rho G. This is another formula. Okay, P equals to H rho G. Therefore, in a liquid of fixed density, pressure rises with the increase of depth. In case of water, it was approximately for a 10 meter increases in depth, the depth pressure increases by an amount equal to the air pressure, that is atmospheric pressure. Okay, my dear students, now come to next page. Density can be increased by compressing air or gas by increasing pressure, but same is not true for liquid. Liquids cannot be compressed in the same way with pressure. So, if density cannot be increased or decreased, how pressure of water is increases when we go from the surface of the bottom of sea. That this figure is shown in here, and here see the pressure increases with increase of depth. Here in x-axis this is depth in kilometers, and this is water pressure, atmospheric pressure, that means ATM. Okay, here see this from this graph we can see that with depth water pressure is increases. Okay, now comes to next mathematical problem. Now I will solve this mathematical problem. Underwater, here given the question, underwater pressure increases by 1 atm from 33 feet 10 that is 10 meter increases of depth, and the divers have gone a maximum depth of 1000 feet, that means 330 meter. How much pressure did they have to tolerate? My dear students, first of all, you have to know ATM, here given ATM. ATM means standard atmosphere. Okay, standard atmosphere, and its symbol is ATM. And unit, this is the unit of pressure. This is the unit of pressure. Now, per 10 meter depth, pressure increases by 1 atm. You have to memorize this formula. Per 10 meter depth, pressure increases by 1 atm or 1 bar. Then, for 330 meter, the depth will be 300. For 330 meter, depth will be 10 meter per atm. That means 33 atm. Okay, my dear students, this is the answer. Okay, now come to next mathematical problem. Calculate the pressure at depth 50 centimeter for kerosene. That is the here given the density of kerosene is 800 kg per meter cube, and the density of water given 1000 kg per meter cube, and the density of mercury given 13,600 kg per meter cube. Okay, now we'll solve this mathematical problem. See, here given the depth, that means h, depth given 50 centimeter. So we have to convert this centimeter into meter. So 50 divided by 100, that means 5 divided by that means 0.5 meter. Okay, depth will be 0.5 meter. And given also the density of kerosene rho, that means rho K, is 800 kg per meter cube. Okay, the density of water, that is rho W, we are given 1000 kg per meter cube, and the density of mercury, that means rho M, equals to, we are given 13,600 kg per meter cube. Okay, now we have to find out the pressure. Okay, so what will be the pressure? Now we know for kerosene P equals to H rho G. Okay, for kerosene P equals to H rho G. Now H has given 0.5 to the value rho K, that means 800 into G means 7.8 meter per second square. So my dear students, doing this calculation we will get that 3,920 Newton per meter square. This is the unit of pressure. Okay, now we can easily find out also the pressure for water. So P equals to H rho W G. Okay, 8 means 0.5 into rho K means 1000 into 9.8. Okay, and again for mercury, we can find out also the pressure. P equals to H rho M G. That means 8.5 into M, rho M means 13,600 into G means 9.8. Okay, my dear students, I hope all of you have understood this mathematical problem. And now come to next mathematical problem. At what depth the liquids, kerosene, water and mercury pressure will be 1 atm. That means standard atmospheric pressure. Okay, we know for mercury pressure is 1 atom at a depth of 76 centimeter. My dear students, you have to memorize this formula. Density of water is 13.6 times less than mercury, therefore the depth of water will be 13.6 times more. So we have to multiply this 13.6 with 76 centimeter. That means the depth of water will be 76 into 13.6. That means 10.34 meter. Then density of kerosene is 0.8 times less than water. Therefore, the depth for kerosene will be 1 divided by 0.8. That means 1.25 times more. So the depth for kerosene will be 10.34 meter into 1.25. That means 12.92 meter. My dear students, your today's SW topic is SW number is 9 and SW topic is math. This mathematical problem. Okay, my dear students, you have to do this on 1, 2, 3 problem for SW and submit it on Saturday. My dear students, I hope all of you have understood today's topic. Practice properly at home. See you again in the next class. Allah Hafiz.